Hello everyone, welcome to this next video on complex analysis. In this video we shall take up this linked question, and this question appeared in 2009. So the first part of this question says, if we are given this function f of z defined like this, then the residue of the function f calculated in the upper half plane is which among these four? So let us first see what is the given region to us. So here the upper half plane is given to us. So first of all, let us draw this complex plane. So this is our y-axis, and the corresponding x-axis would be this dotted line. Why I am creating this dotted line? Because in the region, we are given this region, the upper half plane, y greater than 0. So for y greater than 0, we have this whole region above this dotted line. So dotted line represents we are not considering the region, we are not considering the points on this x-axis. So in this region, this x-axis, that means y is equal to 0, is not included over here. So that is our region. So first of all, let us see whether this function f of z given by e to the power iota z divided by z into z square plus 1, whether this function is analytic in the given region or not. So for that, what do we do? We firstly see the singularities of this particular function. So for singularities, we just equate the denominator equal to 0. So when you equate the denominator equal to 0, from here you see z is equal to 0 and z is equal to plus iota, z is equal to minus iota are the possible points of singularities. These may be singularities. Now, whether they are the corresponding singularity or not, that depend on the given region. So in our case, the region is this one, the upper half plane, right? So that is why we say the point z is not included, because we are not considering this point. This point lie on particularly x-axis. So this point is not included in our region. This point lie below this region somewhere here, right? So this point is also not including. So the only singularity is present at the point iota, plus iota. So that means while evaluating this integral, so we are to evaluate this integral over the given region. So we are to evaluate this integral over the given region. No, we are not to evaluate this integral, I'm sorry. We are to calculate the residue of the function at this isolated singular point. So what would be the residue of the function? So the residue of the function f of z calculated at z is equal to plus iota, that would be given by the formula limit z belongs to iota. And because this is only one singularity, that means it is a simple pole of order 1. Simple poles have order 1, right? So that means we would have this formula z minus the point of singularity, that is iota, and then f of z. So we just have to evaluate this limit. That's really easy. So you just substitute the value of f of z over here. So that would simply be e to the power iota z divided by z and z square plus 1. So you can obviously factorize this term z square minus 1 into z minus iota and z plus iota. So you'll simply have z minus iota and z plus iota. This z minus iota cancels with this one. So you can directly substitute the limit z going to iota. So it would be e to the power minus iota square divided by iota into 2 iota. So it would be e to the power, iota square is minus 1, so it would be e to the power 1 divided by 2 iota square, and iota square is again minus 1, so it would be minus 1 by 2 into e. So that would be your answer. or you can write this to be minus 1 upon 2e. So this is our answer. So let us look at our options. So 1 upon 2e is our option. So here option A goes to be the correct option. Well, that is it for this video. I'll see you in the next question.